Earth. The Earth is the third furthest planet from the Sun and ranks fifth in size. The distance of the Earth from the Sun is about 150 million kilometers. The Earth is made up of the atmosphere, air, hydrosphere, water bodies, lithosphere, solid and molten materials, and the biosphere, living things. About 3/4 of the Earth's surface is covered by water. Currently, the Earth is the only planet in the solar system with water bodies. The Earth is the planet on which we live. The shape and size of the Earth. The shape of the Earth is a flattened sphere. A flattened sphere is known as an oblate spheroid, geoid. The flattening of the Earth is very slight as the measurements in the north to south and east to west distance indicate. The distance through the center from the North Pole to the South Pole is 12,713 kilometers, whereas the distance through the center of the Earth at the equator is 12,757 kilometers. The circumference of the Earth at the equator is about 40,000 kilometers. Evidence of the Earth's shape. There is enough evidence to show that the Earth is spherical. The evidence includes the following. 1. Sunrise and sunset. The sun rises and sets at different times in different places of the Earth. People in the east see the sun earlier than those in the west do, to the Earth's rotation from west to east. If the Earth was flat, the whole world would have sunrise and sunset at the same time. 2. Circumnavigation of the Earth. If you travel from a certain point on the Earth by going straight around the Earth, you will eventually come back to the point of origin. This concept was proved by the first navigator Ferdinand Magellan, who sailed around the world from 1519 to 1522. Magellan in his voyage did not encounter any abrupt edge on Earth's surface over which he would fall. This journey around the Earth is called circumnavigation. 3. Aerial photograph of the Earth. A photograph taken by airplane or images captured by artificial satellites from the air show that the Earth is curved. 4. Ship's visibility. The visibility of an arriving ship which is far away starts with the flag, then the mast and eventually the whole ship as it nears the coast. When the ship moves away, it gradually disappears starting with the ship, then the mast and finally the flag. If the Earth were flat, the whole ship would appear or disappear at once. 5. Lunar eclipse. When light from the sun is obstructed, a circular shadow is observable. For example, during the eclipse of the moon, the shadow of the Earth on the moon appears spherical. 6. The Earth's curved horizon. The Earth appears to have a curved horizon when viewed from a high cliff, plain or a high building. The Earth's curved horizon widens as the observer altitude increases until it becomes circular. The Earth's movement. The Earth is in motion all the time. The Earth has two movements, namely rotation and revolution. Rotation of the Earth. The term rotation means the spinning of a body on its axis. An axis is an imaginary line joining the north and south poles through the center of the Earth. The Earth rotates on its axis in an anticlockwise direction, from west to east through 360 to the power of degrees in 24 hours. This means that the Earth takes 1 hour to rotate through 15 to the power of degrees, which is equal to 4 minutes for every 1 degree. Evidence of the Earth's rotation. 1. The phenomenon that the sun moves from the east to the west is absolutely not true because the sun as the central body of solar system is stationary. Instead, what moves is the Earth, which rotates from the west to the east. It is this movement which explains why the sun appears to rise from the east in the morning and set in the west during the evening. Therefore, the Earth rotates on its axis from the west to the east. 2. At night, most of the stars appear to move across the sky from the east to the west. This proves that the Earth is rotating from the west to the east. 3. When traveling in a fast-moving vehicle, we notice that trees and other objects appear to be moving in the opposite direction. This observation is similar to the movement of the Earth in relation to the sun. Just like the individual moving in the bus, it is the Earth and not the sun that rotates. The Earth's rotation changes from no movement to very rapid movement, although we not feel the motion because we move with it. At the equator, every point of the Earth's surface moves eastwards at about 1,600 km per hour. At latitude 40 to the power of degrees, the speed is about 1,280 km per hour. In the meantime, at the poles, the speed is 0 km per hour. Effects of the Earth's rotation. When the Earth rotates, the following happen. 1. Day and night. The change between day and night is caused by the rotation of the Earth on its axis. The side that faces the sun experiences the light from the sun, day, whereas the side that is not facing the sun at that time is in darkness, night. Therefore, As the Earth rotates, its two parts alternate between light and darkness, respectively. Hence the day and night sessions they experience in turns. As such, different places on the Earth's surface experience sunrise, noon, and sunset at different times in a day. 2. Differences in time between places located at different longitudes. The Earth's rotation results in different times for different locations. The difference in time is determined by longitudinal differences between two or more places. We have learned that the Earth rotates from the west to the east, making a circle of 360 degrees. Then, how long will it take to turn 1 degree? To find the answer to this question, we must divide 24 hours by 360 degrees. But first, we will change the hours into minutes. 24 x 60 equals 1440. Thus, the Earth goes through 360 degrees in 1440 minutes. To find how long it takes 1 degree to rotate, we divide 1440 minutes by 360 degrees. Therefore, the Earth takes 4 minutes to turn 1 degree. As there are 60 minutes in 1 hour, the Earth will turn 15 degrees in 1 hour. 4. Gain or loss of a day when crossing the International Date Line. The International Date Line, IDL, is an imaginary line that was established in 1884. This line follows the meridian of 180 degree longitude except where it crosses land surface. It is located halfway round the world from the prime meridian, the 0 degree longitude, established in Greenwich, England, in 1852. When traveling from the west to the east and you cross the IDL, you gain a day. Conversely, when you cross this line from the east to the west you lose a day. For example, if it is Thursday, August 3, 2 p.m. at 165 degrees west, it will be Friday, August 4, 2 a.m. at 165 degrees east. 4. Deflection of winds and ocean currents. The Earth's rotation causes deflection of planetary winds and ocean currents. This means that they do not blow and flow in the intended direction. The planetary winds and ocean currents are deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This is summarized by Farrell's law, which states that freely moving bodies are deflected to their right in the northern hemisphere and to their left in the southern hemisphere from their point of origin. This is evident in the deflection of winds and ocean currents. 5. The daily rising and falling of tides. The ocean tide is the rising and falling of the water level in the ocean. This is caused by gravitational attraction exerted by the sun and largely by the moon upon the rotating Earth. When the sun, the moon and the Earth are in a straight line, the ocean tide rises, and when the sun, the moon and the Earth are not in a straight line, the ocean tide falls. Tides are experienced at different times of the day and in different places on the Earth's surface. Revolution of the Earth. The Earth's revolution refers to the movement of the Earth around the sun following its orbit. The speed of revolution is about 29.6 kilometers per second. The Earth revolves around the sun for approximately 365 days a year. A normal year has 365 days. The fraction days are not counted every year but is added once in 4 years to make a leap year of 366 days. The leap year occurs once in every 4 years, when February has 29 days instead of 28. Effects of the Earth's revolution. The revolution of the Earth around the sun and tilting on its axis have the following effects. 1. Seasons. A season is the main period of the year with a particular type of weather. Seasons are caused by the inclination of the Earth's axis and the Earth's revolution around sun. The Earth's axis is tilted at angle of 66.5 degree to the Earth's orbital plane, and it is always pointing to the same direction in space. In its revolution around the sun, one of the hemispheres is inclined towards the sun at one period of the year and away from it at another period of the year. For example, in June, July and August, the northern hemisphere tilts towards the sun. Thus, it is summer time. The same months in the southern hemisphere. It is winter because the southern hemisphere tilts away from the sun. Spring and autumn are short seasonal transitions between summer and winter, respectively. Generally, there are 4 seasons in a year that are differentiated by temperature and rainfall characteristics. These seasons are summer, autumn, winter and spring. The 4 seasons are more pronounced in areas found between 23 degrees and 66 to the power of degrees of latitude north and south of the equator. Around 0 degree to 5 degree north and south of the equator, there would be no season because it experiences high temperature and rainfall throughout the year and the sun is almost overhead at those places throughout the year. However, due to variations in relief, seasonal variations are experienced. The area between 5° and 23° north and south of the equator are characterized by hot to wet and cold to dry seasons. At the North Pole, NP, and the South Pole, SP, it is very cold throughout the year and the seasons cannot be distinguished easily. In the Northern Hemisphere, summer months are June, July and August. Autumn months are September, October and November. The winter season occurs in December, January, and February, whereas spring months are March, April and May. In the Southern Hemisphere, the summer months are December, January and February. Autumn occurs in March, April and May. The winter season occurs in June, July and August, whereas spring months are September, October and November. However, due to the presence of relief and oceans, these seasons do not occur in this sequence. 2. Aphelion and Perihelion. The Earth revolves around the Sun in an elliptical orbit. Due to the elliptical shape of the Earth's orbit, the Sun is closer to the Earth at one point of the year than at another. The furthest position from the Sun in the orbit of the Earth is called aphelion. The Earth is at aphelion each year on July 4 when it is 152 million kilometers from the Sun. Perihelion occurs when the Earth is nearest to the Sun, about 147 million kilometers from the Sun. The Earth is at perihelion each year on the 3rd of January. 3. Eclipses. An eclipse is a total or partial obstruction of light from the Sun by either the Earth or the Moon. This occurs when the Earth or the Moon intercepts the light from the Sun. There are two types of eclipses, the lunar and solar eclipse. The lunar eclipse is also known as the eclipse of the Moon. It occurs when the Earth passes between the Moon and the Sun, thus casting its shadow on the Moon. The solar eclipse is also known as the eclipse of the Sun. It occurs when the Moon passes between the Earth and the Sun. The Moon throws its shadow over the Earth. An eclipse of the Sun is partial when only part of the Earth is obscured by the shadow of the Moon. The portion of the shadow that results when the light from the Sun is partially blocked is called penumbra. Moreover, when the light from the Sun is completely blocked, it forms the shadow called umbra. On October 23, 1976, parts of Tanzania witnessed a total eclipse of the Sun. In addition, partial eclipses occurred on April 19, 1977 and October 14, 2000. On September 1, 2016, a total solar eclipse was witnessed in Rujua, Mbarali district in Mbia region. 4. Changes in the latitude of the overhead Sun. The overhead Sun appears to move northwards and southwards between latitudes 23 feet 2 to the power of degrees N and 23 feet 2 to the power of degrees S, that is, between the tropics of Cancer and Capricorn. As a result, places between the tropics of Cancer and Capricorn experience overhead Sun at different times of the year. The places south of the Tropic of Capricorn and north of the Tropic of Cancer never experience overhead Sun at any time of the year. Solstice and Equinox. The tilting nature of the Earth's axis causes parts of its surface to receive different amount of sunlight at different times of the year. This situation results to seasons of the year and two phenomena which are solstice and equinox. Solstice comes from the Latin word solstitium, which contains two words. Sol means sun and sistere, which means stand still. The solstice, therefore, literally means sun stands still. Solstice is a phenomenon that occurs when the Earth poles are mostly inclined towards or away from the Sun, causing the Earth pole which is inclined to the Sun to receive maximum sunlight. This makes the most inclined pole towards the Sun to experience the longest day in the year. During this time, the Sun is vertically overhead in respective tropic on specific dates. The southern hemisphere gets the maximum intensity of the Sun's rays on December 22, which is the summer solstice in the Tropic of Capricorn. At the same time, it is the winter solstice in the Tropic of Cancer. The northern hemisphere solstice occurs on June 21, commonly known as the summer solstice in the Tropic of Cancer. At the same time, it is winter solstice in the Tropic of Capricorn. The equinox simply refers to equal lengths of days and nights. Due to the tilting of the Earth's axis, there are only 2 times of the year when the Sun is directly overhead at noon along the equator. This results in equal distribution of sun rays between the southern and northern hemispheres. The equinox occurs around March 21 and September 23 of every year. The March equinox is referred to as vernal equinox in the northern hemisphere and autumnal equinox in the southern hemisphere. On the other hand, The September equinox is known as autumnal equinox in the northern hemisphere and vernal equinox in the southern hemisphere. 5. Varying lengths of day and night. At different times of the year, the lengths of day and night are not the same across the world because the Earth's axis is inclined to its plane at an angle of 66.5 degrees. Had the Earth's axis been vertical to its orbital plane, all the parts of the Earth would have the same duration of days and nights throughout the year. Places along the equator experience equal day and night throughout the year, but northwards or southwards toward the poles, the lengths of day and night vary with latitude. For instance, when the overhead sun is in the northern hemisphere, the days are longer than the nights in that hemisphere. However, at latitude 66.5 to the power of degrees north, the Arctic Circle, and beyond the sun does not set. At the North Pole, daylight is experienced for 6 months without sunset. During that period, the polar regions south of the Antarctic Circle, 66.5 degrees south, experience prolonged 6 months of darkness and, vice versa, they receive 6 months of daylight as the North Pole experiences darkness.